crowd than the last session, and I promise you it actually feels better because I was in the audience, it was hot. So in the last session, we've got loads of cat memes and even a Bambi animation. So I don't know how to make it as interesting in this one. Anyway, I'm Yoyu. I run a very small studio based in London. I guess if you come to this talk, you guys work for small teams. I hope there are not many of you working in big studios coming here to troll me, but let's see. Today, I'm going to show you some of my experience working in small teams, doing Unity development, and also make use of some cloud-native development. A little bit about, so a little bit about myself. I actually started my career in games as a board game publisher, and I grew the company into about 100 people and until I sold the business and started traveling around the world, but that's another story for another talk. And eventually I think it was around 2012. If you remember that time, everyone was building a mobile startup. Like now everyone's doing indie games. So I joined a mobile startup as a tech co-founder. At that time, it was also around the time that cloud technology started to take off. So I accidentally become an early adopter of cloud technology. The startup didn't go very far, like most indie games. So, but because my knowledge and experience in cloud technology, I got into technology consulting. I started working with a multinational tech consulting company. That's where I improved my knowledge on cloud technology. Also consulted many multinational customers. But I feel a little bit bored because I miss the creative part. It was authentic, not meant to be a joke. So in 2020, I came back to the games industry, this time in the indie games industry. The first project I did, very luckily, was Rings 3 Kingdoms. So I believe, so some of you are noting here, so I believe some of you may have played mobile game Rings. So Rings 3 Kingdoms is the fifth version of this very interesting Tinder-like mobile game. I will go into that later. And currently I'm making a online co-op murder mystery game. So it's a point-and-click murder mystery game with online co-op mechanism. Here, I'm not promoting this game at all. Don't get me wrong. We are just releasing the game like in about 2 weeks. So because a lot of examples I'm going to use in this talk will be about this game, I think it's probably better to get a little bit idea of what the promise of the game is at least. So first of all, it's an online co-op murder mystery game, and it's episodic. And we wanted to offer each episode as a DLC. And as an online co-op game, obviously, we expect the players to be connected to the internet. So there is a little bit kind of like getting the scripts live from like online storage, this bit of elements. So when we make updates on the game stories or game scripts, we don't need to push out a new build all the time. And one interesting thing we have is, unlike a lot of online co-op games, which requires every player to have their own copy, we want to enable the hosts to invite their friends. Their friends don't need to buy the game, don't need to pay for the game. So as long as the hosts owns the game, their friends can join with a free demo for free. So this added a little bit additional requirement for our implementation. Turns out I don't have cat memes, but I do have a Pokemon. So yes, this is going to be a technical talk, but I'm trying to make it as fun as possible. So I defined the kind of like 4 levels. We are going to start from level 1, which I believe if you are here at Develop, you probably already on level 1 already, and we will level up from there. So before we go into the details, maybe I need to explain a little bit like what I mean by cloud native. Cloud native, in my mind, is basically means we are transitioning from servers to services. So for example, if you have a Jenkins build server, even if the set is sitting on the cloud, you still need to maintain the servers. They are not exactly services. But if you have a build pipeline that is using like a cloud native service, for example, like things like Circle CI or GitHub Actions, that I would consider as services. So if we take a step back, like why is this important, or why is this interesting? Some of you may remember like in the past, if you want to copy a file with your friends, to your friends, you may need to carry a USB stick and pass the USB stick around like physically. Or if you want to send across the internet, and I'm not sure how many of you, but some of you definitely have used like something like FTP servers to send files across. Obviously, we don't want to spend our time maintaining servers, restarting the servers. We want to spend our time chill on the beach or coming to develop. So if we can avoid using servers nowadays, and the chance is like for everything you do, you can actually avoid using servers, that will save us a lot of time. Some of the services, so first of all, like I must say that this talk is not intended for experts. If you just come here to chill, yeah, feel free to stay. But what I will cover is actually a range of different services. So for each one, then probably I would stay just at a very introductory level. And I will introduce or I briefly describe some of the recipes we use in our projects, or mostly like in projects I have worked on myself. So I guess most of you probably can recognize some of the services here and probably used some of them as well. But what are we will jump into each of those services later. But what are the benefits for small teams to use these services? Before I come into this talk, I actually had a prep call with one of the organizers. So he used to work with PlayStation, and similar to me, he made this transition from actually it was Sega, sorry, Sega, a studio, a Sega studio, into a much smaller team. One thing he noticed, like a very significant change from a big studio into a small studio, is you actually need to do everything yourself. Unlike in big studios, there is probably a team like maintaining or different like services or build pipelines, for example. In small teams, you actually need to build them yourselves and maintain them yourselves. So that comes back to the first benefit. Cloud native services, they are in general more reliable and need less maintenance, as we are working with small teams. So we don't want to spend our time. We want to spend our time developing the games, making the game fun. We don't want to spend our time restarting servers. So the first benefit of using cloud native technology is it's more reliable. So you don't have to stay in constant anxiety if you are on the beach or coming to develop. The second benefit is it supports a higher degree of automation. So I think this benefit comes down to the fact that those services, they are already online and often offered with nicely packed APIs. So they are more, it's easier to integrate different cloud native services together. For example, I will expand this later, but for our game, we have a very small automation pipeline that check the game scripts. So the game scripts writers write. And this automated pipeline will give writers feedback and convert the scripts in a format used by Unity and notify in a Discord channel once all this is done. So all these processes are packed in one automation process. And last but not least, the last benefit for small teams, I think it's probably a lot of people's interest. It doesn't really cost much for small teams because most of the services, cloud native services, they are charged on a by usage basis. So if you use less, you pay less, and if you are a small team, the chance is you will use much less than bigger teams. So a lot of times, if we talk about the public clouds, a lot of times your usage will fall below the free tier limit. But of course, once your game goes live, the usage may ramp up. But if that's the case, I think it's often a case of a celebration rather than being sad. So without further ado, let's move on to level 1. So in this level, I think you probably will recognize many of the services I mentioned here. So if you come from a Unity world, the chances you probably are using Plastic on day-to-day basis. So Plastic is basically the version control tool that replaces Unity Colab. So for those who are not necessarily familiar with version control is essentially a tool that allows you to manage different versions of your code. For example, if you made an update, but you are not very happy of that, it's causing a lot of issues, you can very easily roll back. So previously in Unity, there's a service called Colab that was about two years ago, I think. And the Plastic is kind of like upgrade to it. One very significant improvement between Plastic and Colab is it supports branching. Branching means you can have different branches for different purpose of your build or your code. For example, you can have a release branch where you build your game, you publish on Steam, and you can have a dev branch where you do your experimental development, so they don't interfere with each other. I don't know how many solo devs are here, and more often I found the solo devs are probably more reluctant about using version control because they think, oh, I just do it myself. Maybe it's actually taking me more time than the benefit it offers to use version control. But in my experience, I do a lot of fun projects myself as well. I really cannot live without version control. If that was you, I highly recommend you try using version control and using branching, and it will save you time in the long run, I think. And an added benefit comes with that using Plastic is you can also make use of Unity Cloud Build. Unity Cloud Build is a service that basically it's a service for Unity that allows you to build the game in the cloud. So you don't need to build the game on your own computer. Instead, it runs a build process online, and it can build like multiple multiple versions, multiple distributions for different platforms at the same time. For example, you can build a PC version and a Mac version, mobile version, all at the same time, if configured well. And to use Unity Cloud Build, well, I'm not 100% sure, but I think I'm kind of 90% sure you have to have a version control tool where Unity Cloud Build can pull code from. So yeah, basically that's how it gets the source code of your project. It is at a very simple level. It's basically Unity Cloud Build is a web-based tool. You just need to click through and then you can configure a very simple build pipeline, and it pulls the your game code from a version control tool such as Plastic, and you can set it up as a build automatically whenever there's a new change set, or you can set it up as, or you always need to manually trigger the build. It's quite easy to get started, and it does have some limitations, but I think in general it's quite easy to get started, and I highly recommend for people who haven't used any build pipeline yet. Surprisingly, in preparation for this talk, I asked quite a few small teams, and I asked them how you use cloud technology. And the most frequent answer I got is actually they use cloud to host their Jenkins server. So although I said at the beginning, Jenkins is not not exactly a cloud native technology, but I think if it works, then it works. There's nothing wrong with doing that. And but it does come with a slightly steep learning curve. Oh, sorry. And so if it's first time you create a build pipeline, and Unity Cloud Build is a really good choice. So, excuse me. So the first recipe I want to show is actually to do with Google Spreadsheets. I believe, so this comes back to the game design part. So cloud native is not development, does not necessarily just apply to develop a coding. It also can help with game design. I believe a lot of designers are already using Google Spreadsheets to host their texts or stats configurations for the game. Why do we want to do that? Because first, you probably want to separate like the game design layer and the game logic layer. That makes your project less messy, and also obviously not all game designers are experts of Unity. So if they can get things done in a more user-friendly interface, such as Google Spreadsheet, also make use of some advanced features of Google Spreadsheets. So it definitely has benefit over configuring data directly in Unity. So the game I worked on, Rings Three Kingdoms. So as I briefly explained before, it's a Tinder-like mobile game. The interaction is you swipe left or swipe right to make decisions, and every time you make a decision, it gives you a new card or new dialogue. So based on the conditions set for each dialogue, so it is a condition-based narrative system. So for this game, there is actually a gigantic spreadsheet that hosts all the conditions and the texts that will appear in the game. I actually didn't invent this game or the format or the narrative engine. So the original designer of Rings, Francois, did a talk. So if you're interested, the original designer of this Rings, Francois, did a talk at GDC 2017, which you can get a much more in-depth view of how RINS makes use of Google spreadsheets in game design. So here I can show you a more concrete example from the game I'm working on. This is it's probably a little bit small, but on the left-hand side in the spreadsheet, what I have is basically 3 columns: the character's ID, the display name of characters, and the description for each character. So what we want to achieve is we want to allow the writers or designers to make changes to the character display names or character descriptions in Google spreadsheet. And every time they make changes, we want the changes to be automatically or as automatically as possible applied to Unity without the need to actually manually put in the data from spreadsheet, download the CSV, put in the project folder. I believe none of us want to do it 100 times a day. So, so this is like a simple recipe to get the data from Google spreadsheet and and apply it into Unity. So there's a catch here: is this process, this recipe probably only applies to development process. In other words, you cannot use it like in a live game for production. The reason is Google Sheets has a very low API limit. It's not supposed to be used for live game. Or you may run into issue as long as you have 5 players simultaneously playing your game. You probably already run out API limit. Google has a Dolet SDK. Although if you go on the Google Cloud reference site, it will tell you we don't support Unity, but well, you can use it at your own risk. It actually works. I actually had a conversation with product managers from Google before about why you want to scare people in your documentation. But yeah, Google being Google, you know, a lot of their products are offered in beta for many years. And the reason is simply because they got many feature requests. And if this is not something they want to prioritize in the next year or two, they just prefer not to actually overpromise this is definitely going to work in production. But the Dolet SDK does work with Unity. The challenge in this process is like consuming many cloud services. The challenge is always actually the authentication. Essentially, authentication means you need to let the Google Sheets API, in this case, to know who you are. And this is not always easy or not obvious, or simply sometimes just there are too many different approaches. And if as a game developer, this may not be something you would work on daily basis. So you don't know, maybe someone you don't know which one to choose. So in general, for Google services, there are always 2 different kinds of approaches. One is, sorry. One approach is you can authenticate as yourself. Another approach is you can authenticate as a service account. I think I always recommend, whenever possible, authenticate using a service account to really just to protect your own privacy. Because if you authenticate as yourself, you probably come across this very scary warning message already, like, do you want to allow this application blah blah to access all your data on your Google Drive? Obviously, you don't know who will end up using your code, so you probably don't want to do that very casually. So use service account is a much better, much secure process, and it also allows you to give much more granular access. For example, you can control, oh, this service account only have access to this spreadsheet, not the other one. You can have more granular control like this. So at a high level, to authenticate as a service account, you will need a Google Cloud account. You can actually create a Google Cloud account for free. I think it's pretty risk-free. After you have a Google Cloud account, go to the Google Cloud console, and there's a service called Identity and Access Management. Basically, that's where you can create a service account. Once you get a service account created, you can download the key for the service account. And the account ID is usually an email. So you can share like whatever Google Sheets or even Google Doc or any files in your Google Drive you want to share. You can share it with this account ID / email address, just like you would do for another user. And once you get the Google Sheets API enabled in this Google Cloud project, you can use the private key and the .NET SDK to access data from Google Sheets. And most Google services, they follow exactly the same template. And so this screen is smaller than I expected, so I apologize. So what it shows here is basically just a snippet of C# code that let you connect to the Google Sheets service and authenticate and start using the service in Unity. As you can see, there are actually not many lines of code, and I probably want to delete the debug log key line in production as well. So it's actually simpler than you might expect it. If you wanted to take a picture, I think the most valuable thing is actually knowing what packages I want to reference on the top left. It's not, the documentation doesn't always make it very obvious to figure out. I actually have a secret YouTube channel, which is no longer a secret anymore. So I actually recorded the video of the whole process I mentioned in this couple of slides. And so if you're interested in, you can take a look. I don't know, and speaking of that, actually, I'm not 100% sure if there's a better way to handle keys in Unity project. So at the moment, we put them in resources, but there is still a risk that the project can be decompiled. But if anyone knows a better way, please let me know. And here I wanted to mention something like really, really simple, but really, really useful, and a lot of people don't know. And it's actually a very good example of how cloud-native services work together. That is, in Google Sheets, you actually have a Google Translate formula that allows you to just translate instantly in the sheet. And Google Translate, in this case, is also a cloud-native service, and it's really handy. I wouldn't use the machine translated stuff maybe in the final game, but as a translating for a placeholder, I think it's really, really useful. So that is level 1. So can I have a show of hands? How many of you are already at level 1? So cool. So I haven't wasted all of your time, so that's good. That's good to know. So let's move on to level 2. So far, we have mentioned the word automation several times already. I think in an ideal world, you should never do repetitive tasks yourself. If you find probably many of you have heard the dry principle. So don't repeat yourself. Whenever you find yourself doing something repeatedly, you should consider it's a sign that you should consider automate it. Because when we're automating tasks, not only it saves your time, it also reduces the chance of making mistakes. Because you do more, and there's more chance you make mistakes. You do less fewer mistakes. And as mentioned at the beginning, using cloud-native services also helps you to actually integrate services together and makes automation easier. There are many different cloud-based, so task runners are designed to build automation pipelines, and there are many cloud-based task runners, such as GitHub Actions and Circle CI. And if you use GitLab, there's a GitLab equivalent of GitHub Actions as well. Under the hood, they all use the same technology, same virtualization technology called Docker. But you don't actually need to be an expert of Docker to make use of the task runners. Although, if you know a little bit more about Docker, that will be definitely helpful. Today, I'm going to mostly focus on GitHub Actions because that's what we use in our project. So I already introduced this pipeline at the beginning. So Whispers in the West is a narrative game, so we have a lot of words in this game. We have a lot of game scripts. Those scripts are what writers will contribute to. So we have those game scripts, and those game scripts come in a very simple format that is designed to be easy to use for the writers. So to load the scripts into the actual game, we need to pre-process the data. So it become a format that Unity recognizes and we can easily manipulate in Unity. So that's the initial reason of building this pipeline. We have a GitHub action defined that this action workflow will run whenever we check in a new change. So whenever we make a change to the game scripts and the check-in changes, this pipeline will run. And it will check the format. First of all, it will check the format of the scripts and give feedback to the writers. For example, if there's a dialogue line that is too long, for example, more than 160 characters, it will tell the writers, oh, this line is probably too long. You probably want to reduce that. So this is kind of like user-friendly design in the process. And it also check out the metadata in Google Sheet, stored in Google Spreadsheet. So we use this metadata to check, for example, if a certain character ID actually exists. We also check things like if the name of the item is spelled correctly. So all this is there to help us minimize the mistakes and give user feedback. Also, at the same time, we pre-process the data and transform into either JSON or CSV or TSV format, and then we can use them directly in the game. So this is an example of like the output from GitHub Actions for the writers. So for example, the line says, okay, this line is too long. Probably want to reduce it. And it also checks the format of the script. For example, here it thinks the writer probably forgot to add a default variation for a certain dialog node. So these are the examples of feedback this workflow gives to the writers. On the right-hand side, this is actually really fresh, fresh off the press. As we are releasing the game in 2 weeks, now we have 8 cases in the game, and a few cases they are translated into several different languages. and it depends on whether they are offered as a DLC or not. They may be encrypted, they may not be encrypted. So in short, there are hundreds of different files at like dozens of different paths. So this automation is essentially to check which files are missing, because especially when localization is involved, sometimes we just lost track of, or if this part has been translated into Spanish or not. We just lost track of that. So this automation is essentially designed to help us to check missing files, and also check like if a file should be encrypted but it's not, or if it shouldn't be encrypted but it is, things like this. As you can imagine, for hundreds of files, if we check it manually, it would take us hours. And in fact, even with this automation pipeline, it takes 2 minutes to run. That's how many different checks we need to do. So this is really handy, save us tons of time to check if everything is in place. We actually output it as a TSV. It's very tab separated values, very similar to CSV. You can open it in like editor. You can filter the output as well. For example, if you just want to check what is missing in the dev environment, you can filter by environment. So this is really handy, really small tasks. I call them micro automations. I think micro automations are in fact more applicable for small teams, because as a small team, we don't really have one person dedicated to maintain the build pipeline. Although the idea is good, but it's really, really difficult to make sure we have one big pipeline that automates absolutely everything. Even if we try to do it, maybe at some point, we have to get this built out, let's do it manually. And then we just forget about this pipeline forever. But whereas this kind of micro automations, they are easy to make, they are easy to maintain, even if you don't use them, okay, so you just don't use them, but it doesn't really have a big impact on your overall workflow. But if it's helpful, okay, good, it saves your time. So for small team, I think the micro automation is really, really, really great, and it's perfectly fine not aim to have a big, fully automated pipeline for everything. And this is an example of a GitHub action definition file. So it defines a workflow. Last time when I did this talk, I said this is really easy, and I got some funny faces from the audience. But if you worked on any of the kind of similar automation pipeline, I think it's actually quite self-explanatory. But if you haven't, and unfortunately, text a little bit small here. So essentially, what it does is the first line of the definition is the ID of this workflow. So this workflow, we use it to update shared data. We call shared data because we have many, if you remember, the game is episodic. So there are many different episodes, but different episodes, they also share some data. They also have some data in common. So this is process to update the shared data in Google Cloud Storage. And second line, it says it runs on Ubuntu latest. It's just a name of a Docker image, that is basically a Linux image. For most workflows you can use, there are a few very popular Docker images you can use, and you don't really need to make a lot of changes to it. So in most cases, it runs on a Linux image anyways. And the name of this particular workflow is updating shared data. This is just a user-friendly name. And then the next lines define the different steps. So again, GitHub Actions made it quite simple for users to define workflows, because there are a lot of already ready-made repositories or recipes. For example, the checkout is basically, okay, I use a repository maintained by GitHub to check out the repository that the workflow runs on. So it's really just to check out the source code and nothing fancy. And then the second step is set up the node, because we set up Node.js actually. So because we use Node.js for the following automated scripts, so we use we need to set up the Node.js environment. And then the following lines, we install the dependencies for Node.js, and then we run a script that defined actually outside the workflow. This is a Node.js script, and one benefit of using GitHub to automate things is it allows you to actually write those automations in high-level languages instead of C#. For a lot of developers, it means they can write it much quicker. Also, there are more APIs they can access to. And then the final step is, it's a ready-made step by some open source contributors. So the first time I configured this workflow, I was in disbelief. Oh, it's just so easy to send a notification to a Discord channel. It's really just this easy. You literally just need to reference this repository and pass the Discord webhook, and then define which message you want to send to a Discord channel, and that's it. So that is level 2. And in the interest of time, I'm not going to expand in Game CI. Game CI is basically remember we talk about Unity Cloud Build. Game CI is essentially a build tool that allows you to achieve the same process but with GitHub Actions. It allows you to define the configuration as code and also gives you more freedom in terms of how you want to define your build pipeline. It can also publish to like Steam Store or App Store. It also has features like this. So that is level 2. So level 3 is object storage. Object storage is, in this level, we gradually move to the public cloud. So comparing to like the previous services which are ready to be consumed, public cloud, there will be a little bit learning curve, but I think the easiest and the most obvious place and also for most people where they started with public cloud is object storage. So object storage is essentially like a glorified version of a Google Drive or Dropbox that allows you to store some assets in the storage bucket, and there's more APIs available. For example, if you want a game that to host dynamic game content, before we mentioned you cannot use Google Sheets because there's an API limit, but cloud storage doesn't come with similar limits. Also, you can store all kinds of different data, no matter it's some like a CSV or binary data such as images. And the high-level process is actually very similar to the high-level process we walked through for Google Sheet API. And again, you can use the Google Cloud.NET SDK for Unity to use the cloud storage API. For our game, we took it a little bit further, as we want to offer the DLCs as dynamic content, but also as DLCs. Basically, the user needs to download a piece of data, but we don't want the data to be static. So that's where we make use of the decryption and the encryption feature of Google Cloud Storage. So basically, our DLC is a decryption key. So that is level 3. It's very, because we are more advanced, so we can run through it more faster. That is basically level 3. Level 4 is actually quite simple because I didn't intend to go into a lot of details. into level 4. The most obvious recipe in level 4 is a fully managed database or cloud-native database. So when I talk to some small teams, I found a lot of people are quite hesitant in terms of introducing any networked feature in their games. I think part of the hesitation comes from the fact that a lot of game devs, because database technology is not necessarily something they are super familiar with, if they do a quick Google, a lot of tutorial ask them, okay, you need to set up your MySQL server. And this is just really very unnatural way, maybe for game developers. So people get scared. Okay. Also, it also comes with a problem that we mentioned before. They have to maintain the server. So, but luckily they are in public cloud. There are so many different flavors of managed database nowadays. And I would say those databases are really very reliable. It's probably much more reliable than most databases you can set up yourself. And AWS Game Tech did a lot of white papers for using DynamoDB in game development. So I'm not going to drill down to details. And in Google Cloud, we have something, there's something quite similar as the Firebase. Firebase, for people who know, Firebase is not only a database, it also comes with like cloud functions, and also object storage. You can also use it to host the website. I don't know, can someone click this video? Okay, never mind. So the idea is this is a prototype of a Twitch integration we made using Firebase. The developer had no previous experience using actually any cloud technology before, but he made this Twitch integration basically it's overlay to allow the host of the game and the participants to pull the Christmas crackers together. So there's a two-way communication between the game and the Twitch integration. So we used Firebase to make this prototype. And this is an example in the game. So that is basically the very high-level solution for this Twitch integration. Basically, we use Firebase Cloud Functions to host up some API endpoints, and we use Unity web requests to communicate with those functions from the Unity side, and then use the Twitch extension, basically a web application, to communicate with the Firebase Cloud Functions. And there are probably very potentially more recipes. This is the last recipe I promised. And I think text-to-speech, I mean, there are probably very divisive opinion about AI-generated text-to-speech, but they are getting a lot better, and ethically because they are trained using actors' voice. I think it's probably better than a lot of AI graphic generators, and OpenAI, obviously. I guess everyone already knows OpenAI, so that is level 4. So 2 very quick takeaways. If you forget everything I said today, forget all the recipes, or none of the recipes actually apply to you, I think 2 very quick takeaways is every time if you do something in the future, find yourself, repeat yourself, ask yourself, can I automate this? And second, if you ever feel like, oh, I need to set up a server, or I need to have a Raspberry Pi or have my computer running 24 hours, the chances there is a cloud-native alternative. You probably don't need a server. So that's me. Thank you.